Okay, hello everyone. Welcome to our third lecture of the summer. So today we're going to be talking about what load balancing and scalability are, because these are really essential parts of the design process of an application. And then we'll be going over the application to a lot of real life and very major businesses we see around, such as Instagram and other major applications we'll be going over later, how these concepts can be used in these real life scenarios. So first, we're going to be going over what load balancing is and different types of algorithms that are necessary for this concept to work. And then we'll be going over scaling and what the different types are. And then thirdly, we'll be going over more in depth for these specific different types of scalings, which are vertical and horizontal scaling. And then fourth, we'll be going over like different examples in real life of the companies that utilize these concepts in their business to expand them.
All right, so first we'll be discussing load balancing. So essentially, load balancers are going to distribute network traffic through a system of backend servers, and it's going to do so through several regions. Regions as in like worldwide geolocations. So basically, it's going to allow each server to have a lower demand and stress placed on it because of the amount of handling of client requests distributed across these different regions and servers. And through this is basically going to be able to have applications run faster and increase responsiveness. So in context of our real world, we have like, everybody knows we have like millions of users and client requests being sent every second. Every time you're on a website, you're clicking a button, pressing a sign up form, submitting something online, you're sending a client request. And with all these requests across the entire world, we need load balancing to kind of organize them. All right, so next we're going to go over 4 different examples of load balancing in the form of algorithms. So the first one I'll discuss is least connections. This algorithm is basically going to have the request sent to servers from the client based on the amount of connections it has. And it's going to take into account computing capacity of the load balancer. The next type of algorithm is going to be the least response time, which by its name basically sends the request to a specific backend server based on the fastest average response time and the connections. Next is the round robin algorithm, in which the server is going to distribute server requests through a queue data structure, which basically allows for more organization. And finally, this is like probably one of the most important ones, is the hash and IP hash algorithms. And what the way this works is it's going to take in data like an IP address or URL from a website, and it's going to create a hashing key through this. And using the hashing key is going to basically organize how the data is being distributed across several load balancers and regions. So yeah.
All right, so let's have an intro on scaling. Okay, so what is scaling? So I would like to ask you guys to think about a scenario. So think that you created your own website and it provides a service. So like think about maybe you created a website like Amazon or eBay where users can buy and sell stuff. And let's just say like in the first month, the website is going super well. There's a good amount of people coming, but suddenly like in the next month, like maybe you get a sponsorship or like some type of advertisement from like a influencer or something. So your website suddenly gets a lot more users. So the number of user visitors starts to increase exponentially. Then you realize that your website actually cannot handle the large amounts of new requests. So this is actually basically the website reaching its scalability limit. So scaling in simple terms is basically trying to expand your project's accessibility, power, and presence. We're basically trying to meet your user demand, right? So your website always has like a set limit on how many like user requests it can handle. And above that, your website might end up crashing or actually like fail. So we want the ability to serve the clients effortlessly, even when demands change abruptly through scaling. And this is kind of analogous to fast food chains, right? So like McDonald's and KFC, when they first start, they're basically one restaurant, right? But once they become more popular, they start like spreading across maybe the US and internationally, so they can actually meet the users' demands. And there are different types of scaling that we'll be talking about later on, which is called horizontal and vertical scaling. And basically connecting this back to load balancing is that load balancing is actually an option for scaling. So you guys can see like in the picture here, I have a brief summary. So vertical scaling, you can think of it as basically kind of upgrading your computer, like your specs for your computer. And horizontal scaling is actually kind of just buying more computers to help.
Okay, so there are two types of scaling. So vertical scaling and horizontal scaling. So let's bring back to the original scenario. So like you're like new startup and it's a business model is similar to eBay. And let's call the business model like eBay. So like you're trying to sell stuff on the internet. And there are like people from different client and they're trying to access the items from your database through the server. So now you have an influencer. The influencer like advertise like your product, like advertise like your website, and now it gets a lot of attraction. So there are even more clients that want to buy stuff from your website. So that means that like your servers will receive a lot more requests than before. So the ways to handle that is through like scaling. So what vertical scaling is that like say if you have like one server, like one machine in your backyard basement, and the vertical scaling makes sure that like your machine is able to process like much faster than before. So it's still one machine, but now instead of like maybe 1 billion calculations per second, it's like 100 billion calculation per second. So vertical scaling makes machine like even stronger and faster, but it's still one machine. So like the advantage of this is that like you still have one machine. It's easy to control. Like you can just make a command to the machine and the machine will make a command back to you. And upgrading this machine is also quite easy. So like you just replace the machine with some more advanced version. And it can also scale like in memory, in storage, and in network speed to meet your specific need. So the few advantages of this is it's cost effective. So like you just like replace the server and with a better one, and you can have a scale in the vertical direction. And it's also less maintenance because it's just one machine. You don't have to like as many like machine problems you have to worry about. But there are also still disadvantages to this one because you only have one machine. It's very easy for like single point failure to happen. What single point failure is that once your server crashed down due to maybe like a DDoS attack or like a cyber attack of any sort, like there's many requests that's going through your server, and your server, even though your server is really strong, like it can handle 100 billion calculation per second, but the DDoS or other type of cyber attack are way stronger than your calculations the server can handle. So if the server crashes down, like your entire service will be down, right? Because you only have one machine. So that is one disadvantage of vertical scaling. There's another one because the machine is only one. Once it's done, it takes some time for you to fix the machine. So if it's done, like your entire server will be done the time it takes for you to fix the machine. And now we're going to go to the horizontal scaling. So the two arrows, the vertical scaling have the single point failure and the amount of time it takes to fix the machine can be fixed with horizontal scaling. So what horizontal scaling is that instead of having only one machine, you can have multiple machines. So instead of making the processor speed of one machine 100 times faster, you buy 100 more machines for you in your backyard basement, as long as you have enough physical storage in your backyard basement. So this one fixes the single point of failure. How? Because if one server crashes down, there's like 99 more servers that can help the website to like handle the requests from the clients. And if only one server or like maybe a dozen servers crashes down, you still have like maybe like 80 machines that can help keep the client requests going. So that are the advantages of horizontal scaling. So it basically complements the disadvantages of like vertical scaling. But there's also some disadvantages for horizontal scaling. It increases the initial cost because like you have to buy a lot of machine and each machine is cost the same amount. It's much more expensive to buy multiple machines than just upgrade like a single one. And it's also increasing in control management complexity. So you have multiple machines, you have to have a better or more sophisticated algorithm to control and handle all those machines at the same time. So to ideally, like you want to have like vertical scaling and horizontal scaling both ways. So you want to like vertical scale your machines in some direction and horizontal scale your machine in some direction. So like the advantage and disadvantage of them can complement with each other.
Okay, so now I'm gonna tie this all together into how companies actually use this in their business model and how it helps them be successful. So as I mentioned, Instagram is one of the companies that definitely they definitely use this a lot for their success. So just for some quick information, they do have two backend database systems named Postgres SQL and Cassandra, as well as 3 data centers. So the advantage of all these is that all the client requests are being distributed. So all the requests aren't being overloaded at one center. So that allows for the request to be handled faster. And then there's also the round robin algorithm and IP hashing. And these are used to assign users to different server regions. And it's just these algorithms allow the client request to be organized. And this also adds to the appeal of these big companies because they process information very fast, and it's very easy for like users to navigate them because they're very real time. So it's very useful for them. And then this continues with other companies, one of them being YouTube. And as I mentioned, that they have a large amount of load balancers, and they also have organized cluster of servers to handle front-end servicing. So just as Instagram has, YouTube also has a lot of measures to make sure that they have certain speed and reliability due to the large amount of load balancers. So even if like one data center goes down, like there's still a lot of up running like data centers to like process the information, and it allows for quick speed and reliability, which is something we depend on YouTube for. And finally, Facebook and Google, you can see that they invest a lot of money into their data centers, with Facebook investing 20 billion and 13 billion. And obviously this is for a very good reason, because they want to have the horizontal scaling, increasing the number of data centers, allowing them to expand their audience. Even though they are some of the biggest businesses in the world, they're still continuing to grow and continue to adapt. So we can see that because of their thought process and how they are utilizing their budget, they're able to expand their brands. And yeah, they're using these concepts of system design to be a successful organization. Okay, so thank you for listening. Do you guys have any questions for us?
Okay, I think I can answer that question. So like, there's actually one disadvantage of vertical scaling that I have not actually talked about. So that is technological threshold. So basically, like even if you have like infinite amount of money, like when you upgrade like vertically for like some amount of time, like you will reach like a threshold that you cannot just surpass, because like the applied physics of what we know today cannot make the machine run any faster. Yeah, so that is why like sometimes horizontal scaling is a better choice. But if you have like a lot of money, I think it's easier to scale vertically like as a startup. But there's also another disadvantage to that, because like if you only have like few machines, it's very easy for like your servers to crash down in case of there's a like cyber attack.